Hi everyone, Professor Sebastian. Welcome back to our statistics class notes. We're now on page 88 in section 6.2 where we're talking about the normal distribution. And we're finishing off the previous example where I just want to do the probability that z is less than or greater than or between some different numbers. Okay, so this is easy to do because so for the first thing, if I want the probability that z, that means we're going to use the standard normal distribution, which has a mean of 0, standard deviation of 1. So if I go 1, 2, 3 tick marks to the left, that's minus 1, minus 2, minus 3. These are z-scores. And I want to be less than minus 1.25 right about here. This is the area I want, which again, we must use the normal calculator. So I'll go back to that. Normal calculators right here. I already have the mean and standard deviation of 1. Remember, how do I get the normal calculator? I go to stat, calculators, and then normal down here. But we already have it up. So I'm just going to put the mean of 0, standard deviation of 1, leave it there. I want less than, so I change the sign to negative 1.25. And that area will pop out, and I'll get to 4 decimals, 0.1056, which is what I wrote back in your notes. Exactly right here. So if I want greater than minus 1.25, notice that's this other area. I actually don't need to go back to my calculator because remember, this area and then this area must sum up to 1. So since I already found this area which I'm trying to find will be 1 minus 0.1056, what I found to be the area to the left of negative 1.25. So the area to the right of negative 1.25 down here is going to be 1 minus 0.01056, or 0.8944. That's the complement of z, the probability of z being less than or equal to negative 1.25. Now if I want the probability that z is between two numbers, minus 1.96 to 1.96, I'll go back to my normal calculator, and I got to go up here and click the between button. And so now I can say, remember, this is z because I have a mean of 0, standard deviation of 1. So I'm going to put minus 1.96 here, and I'm going to put positive 1.96 here. Hit compute, and it comes out to be 0.95000 to the 5th decimal place. Look at, that's our 95%. So remember when we had the empirical rule and it said that within 2 standard deviations of the mean, it's really within 1.96 standard deviations of the mean, but we don't want to be that precise when we're using the empirical rule. So I'll go back to my notes, and that comes out to be the probability that z is between negative 1.96 and 1.96 is 0.9500 to 4 decimals, or 95%. So if I want the probability that z is less than or equal to negative 1.96, that's this area to the left of it, or the probability that z is greater than or equal to 1.96. So that means it could be in here, or it could be in here. I already figured out that this was 95%, so the outside, of course, is 5%, or 0.05. Okay, let me just do another example or two. For IQ scores for all humans are normally distributed, the mean of 100 and a standard deviation of 16. So what symbol do we use to represent the value 100? Remember, that's the mean, so we use mu, the little Greek u, mu, that's 100. And what symbol for the 16? That's the standard deviation, so we use sigma, because these are coming from a probability distribution, the normal distribution. So they're a population parameter. They're not a sample statistic. Someone has an IQ score of 80. What proportion of the population has an IQ score lower than this? So that is asking for what's the proportion or the probability that X is less than 80. So I kind of drew my picture here again, a standard bell curve, the mean of 100, standard deviation is 16, so minus 16 is 84, minus another 16 is 68, so 80 is somewhere in here. So the area to the left of it is this guy. Now how do I get that? I get that from my normal calculator. I have to change my, what was the mean? It was 100 and a standard deviation of 16. So I changed my mean to 100, standard deviation to 16. And I don't want between anymore, so I'm going to go back to standard. I want the probability that X is less than 80. So I compute. And there's the probability. It's exactly like what I had in the picture, so that's 0.1056 to 4 decimals. 0.1056. Okay, and that's it for now. We'll come back.